Millions of us have petrol mowing machines of different shapes and sizes, and I've been wondering how difficult it would be to convert one to run on an electric motor instead. Not only would it save a lot of petrol money, it would be so much quieter, wouldn't it? Small engines, especially two-stroke ones, are noisy and smelly. You might have noticed.
Ooh, look, what a surprise.
What's in the first?
Nice.
Anyway, Vevor kindly sent me a nice shiny motor so I could experiment with it. Thank you, Vevor.
That's on off. And that's forward, reverse.
Oh, well, that could be handy.
And then 3 speeds. So 1, 2.
4,500 RPM. Very nice. Thank you very much, Vevor.
Now, this is a 60 volt, 2 kilowatt motor, and it's so powerful it could probably drive a small car. In fact, they already do. Well, you know, a small car at least. And perhaps I'll make one of those one day. And certainly it would power a locomotive for my railway, wouldn't it? And I'll definitely make one of those one day, maybe even this summer. But in the meantime, this motor is part of the mowing machine experiment. I hope I can just interchange it into other machines as I make them. Anyway, I have this old mowing machine that doesn't have an engine at all anymore, so it's a good candidate for a conversion. You can see where the engine drive shaft used to engage with the gears inside. Now, I think most modern machines use V-belts and pulleys instead of cogwheels, and of course they're much more forgiving. So if we can make this work with cogs, then you should find it easy to convert a modern machine. Easy! I guess every machine will have its own challenges though. Now the problem with this one is I can't just put the right cogwheel on the end of the motor shaft and away we go, because the motor physically won't fit inside. So I'm going to have to use a secondary shaft, also called a lay shaft, that sticks out of the gearbox and then drive that shaft from the motor somehow. And holding that lay shaft securely in exactly the right position is the hard part. Except, of course, the original petrol engine already had a shaft in exactly the right place, didn't it? Doing exactly the right thing. Ashley and I stripped down the other mower, the newer one, to have a look at it properly.
Ooh.
Out of balance.
It didn't take very long actually. It all came apart surprisingly easily, and we could always put it back together again if we want to. We just have to play back this video in reverse to see how to do it.
I don't know why it wasn't running right.
Where's the grass?
Down there.
Yeah, there's a lot of grass in there. But apart from that, it looks fine, doesn't it? Okay, so we'll try and get the gasket off without breaking it, but if we do break it,
It's gonna break.
that's what happens.
It broke.
Oh wait, take long, did
It
it?
broke again.
The trouble with rubber mallets, they don't really work, do they?
No.
Oh, the whole top. I thought it was going to split. Ooh.
It's worn, but it's not bad at all, is it?
No.
What it leaves us with... it's a dark hole. Yeah, okay. Well, we know that bit will work.
Shut. Got some mighty teeth on there.
Gently does it. Or not.
Nah, the wrong end came off. You have to take off the bolt. Later.
Okay, finally. Very hot bits of puller. And we should be able to get at the bearing now. On that side.
Slide off.
Good. Could be hot.
And there you have it. The main drive shaft of the engine is held in just the right place by two big bearings, and the cogwheel on the end engages perfectly with the cogwheel inside. The only problem is that this shaft is not straight and it has a piston attached to the middle of it. It's a crankshaft, obviously, and it's cranked around and round by the piston. Now you can sometimes just unbolt the big end in the middle and remove the piston. So you could use the shaft like that, but the shaft then, it would still be crank shaped, so it wouldn't be balanced and it would vibrate horribly, probably. No, definitely, it would definitely vibrate horribly. So the plan, my cunning plan, is to replace the whole crankshaft with a straight shaft and use the same bearings and the same housing and the same cogwheel on the end and just leave out everything that we don't need. So that should be easy, surely. Now I know you're thinking that your mowing machine doesn't look a bit like this one, but seriously, if it has a 2-stroke or a 4-stroke petrol engine, then the principle would remain the same. It will have a shaft down the middle, and if you can spin that shaft with a motor, then it will work. The whole thing will work. And you won't have to replace the bearings or the gears or the housing or anything. In fact, the only thing you need to replace would be the main shaft. Now, I'm lucky enough to have a metalworking lathe. It's more than 100 years old, but it's still working. So, of course, I had to have a go at making my own straight shaft. But any engineering shop would be able to make something up for you, because this sort of job is about the simplest job you could do on a lathe. In fact, these days you can send off drawings to online companies that will do it for you, and then they'll send it back to you in a little parcel in the post a few days later. And maybe I should have done that, because, you know, my work isn't the tidiest and this is only mild steel, but I'm really enjoying learning this metal turning stuff. What fun it is to take a piece of rusty bar and turn it into something shiny and useful. Now the cogwheel is tapered inside, so I needed to taper a section on the shaft. But actually that wasn't difficult at all. It just took me a while because I was worried that I go too far, which would mean starting again. In fact, I did everything very slowly for fear of breaking something or turning too much off. But I managed in the end, and next time Ashley came round, we tried fitting it.
I could hit it, if in doubt. See, don't you like coming to work when it goes in like that?
Just hit it.
Very good. Right, so this is the crucial bit. Is the width correct?
Miles away.
Ooh. How does it feel?
Yeah, that's good.
Good.
So
All
this
right.
is the
We don't know whether it's turning the cogwheel or up. Would it? Okay, that's a special one that doesn't want to come off because it's doing something else as well.
We took the gearbox cover right off.
nut underneath, I think.
Nut underneath. Nut? No nut.
To check that the cogs were fitting together properly.
Ta-da!
Yeah, we've been here before, haven't we? I remember this. Looks good, Nick, doesn't it, actually?
It's milky.
It looks like
water in it.
treacle. Or, yeah, it looks like
Cup of tea.
cup of tea. Doesn't it? Who's put tea in the engine?
And discovered that the new shaft was just a little bit too long and it was fouling the bronze gear inside. Now, it just needed to be shortened, but it's good that we checked.
So we had to cut the end of the shaft off.
We also adjusted the slipping clutch just by a little bit. This is to stop damage if the blade gets jammed on something and everything stops suddenly.
Got to hold that in and stand on that while you do that.
Yeah.
Did it move?
Yeah.
But not too much.
No, it's only done.
We did this because there is a slipping clutch installed, so obviously it makes sense. But I don't think that you'll need one if you use a V-belt from your motor, because they slip if they have to. And if you do use a sprocket and chain, as I do in this, then perhaps it's worth including a shear bolt to hold the sprocket on, if you can. I don't know how important that is, though. Perhaps someone can tell us what happens when a motor is stopped suddenly, but you turn off the power, immediately. Has damage already been done somewhere? That's the question.
Right, so now, if you turn it, it should turn that thing. Look at that. It's good. Yep. So far, so good, right?
Anyway, next I went back to the lathe and I added threads to both ends of the new shaft. Even though I'm just using a die to cut the thread and not the lathe itself, it's handy for holding the shaft, and you can use the end stock to push on the die at the right angle. And of course you can rotate the piece easily too. Lathes are just great, aren't they? Now it's going to need a washer, but the thread seems fine. Then I cut the end off, but the tripod leg was touching the lathe, so the world went quite fuzzy for a while. The other end has a smaller thread on it because it has to go into a small sprocket, and the hole is a funny shape so that it won't spin on the shaft. Then I used my marvellous plasma cutter from Extreme Plasma to cut out a mounting plate. Of course, you could use an angle grinder and drill to do the same thing, but those narrow slots would be tricky. That plate bolts straight down onto the crankcase, and the narrow slots are so I can adjust the tension on the chain. And that's it. Well, you know, so far, of course, I need to mount the battery and the controller and other things, and I'm waiting for real connecting links for the chain and not just a little bolt. Now, of course, I don't know how well this is going to work. I hope to show you it in action next time, if ever it stops raining. But for now, at least I know that the principle works, replacing just the engine shaft and leaving out everything else that's not needed. And if you happen to have a Villiers engine lying around that doesn't run, I'd appreciate it. So I could move the motor onto the older machine and put the engine back into this one. Then I'd have two mowing machines. One by each hand. No, Tim, no.